Okay, this first lesson is going to be a review of material that you saw in Algebra 2 on functions, and what you see on the screen here is actually is a variation of the study guide material that I gave you a link to on my class page. So I've made a few changes, but basically it is linked to your text, section 1.1. We're going to be talking about what a function is and what a relation is. You may recall that a relation is simply a set of ordered pairs. Let's take a look at a set of ordered pairs down here in example 1. The minus 3 is paired with a 5, minus 1 is paired with negative 12. Anytime you have a set of ordered pairs, that is a relation. What makes a function special, as you may recall, is that in a function, every value of x is paired with exactly one value of y. So in this case, minus 3 is paired only with the 5. It is not also paired with another number. If that was the case, it would not be a function. So when you are looking for whether or not a representation of a set of ordered pairs is a function, you are looking to see whether every value of x is paired with exactly one value of y. The domain of a function are simply all of the values of x in that set of ordered pairs. The range, all the values of y in that set of ordered pairs. The values of x, the domain values, are the independent variable. In most cases that would be x, and the y values are typically called the dependent variable. When we work with functions, we also work with function notation. Here's an example. F of w is equal to 4w cubed, that's supposed to look like a cube, minus 5w squared minus 7w plus 13. And we typically try to evaluate this function at particular values. So in this case, if we wanted to evaluate f of negative 2, I think you remember that you need to substitute negative 2 wherever you see the w in the function. What you need to be careful about with things like this is using parentheses correctly so that you can take care of that minus sign appropriately. I think if you substitute negative 2 in here and do the appropriate arithmetic, you should find that this function has a value of negative 25. You might want to try that before you go on to see if that makes sense. Sometimes we're working with a piecewise defined function, which is simply a function that comes in several pieces. And the piece that you use is going to depend on what the values of x will be. So if I wanted to calculate the value of f of 0, 0 is a value of x less than 3, so I completely ignore this piece. Substitute 0 in here, 2 times 0 plus 1, to get a value of 1. So f of 0 is equal to 1. If I wanted to calculate f of 5, 5 is a value of x greater than or equal to 3. So I use this piece. 5 squared minus 2, 25 minus 2 would be 23. If I want to calculate f of 3, again 3 is in this piece because x is greater than or equal to 3. So 3 squared minus 2 would give you 7. One of the things you'll be called on to do from time to time is to talk about the domain of a function. And sometimes the domain is explicitly stated. There's no question what the domain is. For example, in the piecewise function we just talked about, since x can be less than 3 and x can be greater than or equal to 3, x can be any real number because that's what's included in this set of values. However, sometimes we are limited in the values of x that we can use. So here's an example down here. F of x is equal to the square root of 5x minus 8. Your book talks about the implied domain because there is something about this that tells us x cannot be any real number. The fact is that with radicals, we're concerned about the radicand being greater than or equal to 0. 5x minus 8 must be greater than or equal to 0. And if you solve that for x, you'll find that x must be greater than or equal to 8/5. So the domain, x is greater than or equal to 8/5. The concept to remember here is the radicand must be greater than or equal to 0. In this situation where we have a fraction and where the danger part is the denominator, we want to be sure that the denominator is not equal to 0. So 3x plus 1 cannot equal 0, which implies that x cannot equal negative 1/3. In general, a lot of the functions that you're going to see will be as like this one in example 2, a polynomial. Polynomials are going to have domains of all real numbers. There are no problems with radicals, there are no problems with denominators. Piecewise functions, you can look over here and see information about the domain directly. If it's a radical, be concerned about the radicand. If it's a fraction, be concerned about the denominator. Okay, two last little pieces of information. One is that when you are considering the range of a function, it is almost impossible to work with or to predict what the range is unless you know something about the graph. We'll talk more about that later, but you are not expected to be able to look at a function such as this or this and know what the range is. You must know what the graph looks like. The last item is that just a reminder that when you're working with function notation, you set whatever you see in here is substituted in its comparable locations over here. So for example, f of 2, substitute 2 for w in here. F of star would be 4 star cubed minus 5 star squared. F of x plus 1 would be 4 times x plus 1 cubed minus 5 times x plus 1 squared, and so forth. That's important to know because when you come down here to talk about difference quotients, you will have to make substitutions with expressions rather than numbers, and that substitution piece, that the concept of substituting is going to be very important for you to be able to do that. Again, this is something that you very likely saw in Algebra 2, but we are going to go over it again. So I hope that's helpful, and we'll talk about this in class and see how things went.